Hello guys, welcome back to my channel Chem with Dishika, and now we are here with another set of questions, and this time we are having the questions of inorganic chemistry. Let us have a look at them and the approach to solve them. So here the first question that we have says the number of pi bonds, sigma bonds and lone pair of electrons in pyridine respectively are. So basically in this question it is asking that you have to calculate how many sigma bonds, pi bonds and lone pairs are present in the structure for pyridine. So to answer this question we first must know the structure for pyridine, and we know the structure for pyridine can be represented as, so just like benzene, here we have the heteroatom that is nitrogen, and similar to benzene we have alternate double and single bonds. So this is the structure for benzene, and here if I replace one carbon atom by nitrogen, then it gets the structure for pyridine. And since we know that nitrogen has got 5 valence electrons, so it has bonded to 3 atoms, basically 2 carbon atoms, 1 double bond and 1 single bond. So we are left with 1 lone pair of electron, that is this, in order to complete its valence shell. So here if I have to calculate the number of sigma bonds and pi bonds, first let me complete the valencies, that is the remaining valencies will be occupied by hydrogen. So this is the structure for pyridine molecule. Now here you can count the total number of sigma bonds. So we know that what are sigma bonds? Sigma bonds are the single bonds that are formed. So you have to count how many single bonds are present in this structure. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So in total there are 11 sigma bonds which are present in this compound. Do not forget the single bond that is present between carbon and hydrogen in hurry. Alright, so when you will count all the sigma bonds, it will come out to be 11. Let us now move on to our pi bonds. So what are pi bonds? Pi bonds are formed above sigma bonds, right? So here this bond represents the pi bond. So there is 1, 2, 3. In total there are 3 pi bonds which are present in this structure. Next, if we look at the lone pair, then there is only one lone pair that is present on nitrogen atom, which is not involved in resonance. It is a localized lone pair. So therefore the lone pair would be equal to 1. So now let us see the correct set of answer that represents this. So that is 11, 3 and 1. So this set represents the correct solution. So therefore third will be my correct set of answer. So I hope you understood this question. The only thing that you need to know for to solve this question is the structure for pyridine, and do not forget the single bond between carbon and hydrogen. Alright, so let us now have a look at our second question. What does it says? So here we have our second question, which says the element expected to form largest ion to achieve the nearest noble gas configuration is. So here the question, you have to understand the language of this question. So what it is trying to say is you have to tell the largest ion. So basically that ion which is larger in size, which is to achieve the nearest noble gas configuration. So here if you see the nearest noble gas configuration, what is the possible nearest noble gas configuration? Hydrogen, helium, neon, argon, krypton and xenon. This is the set for your noble gas, right? And for second period elements, all of them are second period elements. So basically here except for sodium, so here for second period the nearest noble gas is neon, which has your atomic number that is 10. So here if you see, oxygen has got an atomic number which is equals to 8. So it needs 2 more electrons in order to obtain the nearest noble gas configuration. So therefore it becomes O2 negative because it gains 2 electrons. So that's why now it has 10 electrons and now it has gained the electronic configuration for neon. Now if I talk about fluorine, fluorine has got an atomic number that is 9 and fluorine needs only one electron to attain the noble gas configuration. So therefore it will be only gaining one electron and therefore it will be F negative, right? Then we have nitrogen. So nitrogen has got an atomic number of 7 and how many electrons does it needs? Now it needs 3 more electrons. So it will be N3 negative. Lastly we have sodium. So in the case of sodium, what do we need to do? Sodium has got an atomic number of 11. So it needs to lose one electron so that it can gain the nearest noble gas configuration. So here if it lose one electron, it will be Na plus. We know that cation means if there is a formation of positive charge, it means that cations are being formed and cations means loss of electrons, while the negative charge indicates that the electron is gained or the reduction has taken place. So here the question says the largest ion. So you have to compare amongst these isoelectronic species. Now this becomes the set of isoelectronic species. What are isoelectronic species? That are containing same number of electrons. When you have written their configuration, then you will find that all of them are having same number of electron, which is equals to 10, right? So here you have to compare the size of all these elements and you have to tell the largest one. So we know that more the negative charge, greater is the size of ion. So here if I arrange them in the order of their size, the smallest size would be of Na plus because it is a cation. Then the size would be greater for F negative, then it would be O2 negative and the highest would be for N3 negative. So you can see greater the magnitude of negative charge on the element, greater is its size. So this is the order for size, and in the question I have to report the largest ion. So the largest ion would be for nitrogen. So the correct option would be my third choice. So I hope you understood this question. Basically using the concept of isoelectronic species and the size, that for cation the size is smaller and for anions the size are greater, and amongst anions also you have to choose that one out which is having the greatest magnitude. Greater the number in negative charge, more will be its size, and contrary to this, greater the magnitude of positive charge. If the positive charge is greater, then smaller size would be there. So as the positive charge increases, the size of element decreases. It is inversely proportional. Alright, because positive means the electrons are losing, the effective nuclear charge is increasing, which results in a smaller size. Alright, so this was all about this question. I hope you understood the concept behind it. Next we have the question which says, the stability of copper 2 plus is more than copper plus salts in aqueous solutions is due to. So it is saying why copper 2 plus is more stable as compared to copper plus. So what is the reason behind that? You have to tell me. So this you study in the chapter of D block elements, and it is written very boldly in NCERT that the copper 2 plus compensates for higher hydration energy. So it is because of the hydration energy. When you dissolve copper in your aqueous solution, the energy released is called as the hydration energy. So for copper 2 plus, the hydration energy is very much, which compensates for the second ionization enthalpy of copper. So which is why copper 2 plus is more stable as compared to copper plus, because you know that copper has got an atomic number which is 29. So for it we write the configuration as argon 3d9 4s2. But here what happens is this becomes the converted D system. Since we know that here full filled or half filled orbitals are more stable, so this becomes the case of argon 3d10 4s1. So this is the final electronic configuration for copper. So here if you lose one electron, although now it has gained the noble gas configuration, but still copper 2 plus becomes more stable because of the higher hydration energy. So this is the reason behind it, and it is written boldly also in the NCERT. So you need to understand each and every line of NCERT very carefully. You can see how directly the question has been asked from the concept itself. So here the correct option would be hydration energy. That is my third option. First ionization enthalpy, enthalpy of atomization, and second ionization enthalpies are incorrect because they do not hold any relevance in the concept. The only thing that you need to do is that here you need to know that this hydration energy compensates for the second ionization energy, which is why copper 2 plus is more stable. So the correct choice would be my third one. So I hope you understood this question well. I hope you understood all the concepts behind these three questions, what all concepts we have used. So let's meet again in another set of video. Till then, if you like this video, do not forget to hit the like button and do comments in case if you find any doubts.